Which of the above assumptions is correct? Scientists studied the vernal window, transition period from winter to the growing season. They found that warmer winters with less snow resulted in a longer lag time between spring events and a more protracted vernal window. This change in the spring timetable has ecological, social, and economic consequences for agriculture, fisheries, and tourism. As the ice melts earlier, the birds don't return, causing a delay or lengthening in springtime ecological events. Global warming is causing springtime to come early and for longer durations. See, this is a particular instance. It's not a continuous phenomenon. Scientists studied the vernal window. They found that warmer winters with less snow resulted. It's not resulting. Resulting continuous phenomenon. Resulted particular instance. This change in spring timetable has, not having, has particular instance. So we cannot say global warming is causing springtime to come early and for longer durations. But if you access the source text, this is happening because of global warming, and UPSC says this is the right assumption. Just search this passage on Google, you will find the source text. It says global warming is causing this, but if you go by information given in passage and follow the logic, I would say this is incorrect. But UPSC says this is correct because they have access to the source text. Early spring and longer period of spring is not good for bird populations. As the ice melts earlier, the birds don't return. This indicates the migratory behavior of birds. We cannot say it's not good for bird population, so this is wrong. According to UPSC, this is the answer. But if you stick to the information given in passage and logic, I would say this is the most appropriate answer. Here and there you will find some passages like this. You have to handle them at best of your capability. Most logical, rational and crucial message. A global analysis of nitrogen use efficiency, a measure of the amount of nitrogen a plant takes in to grow versus what is left behind as pollution, says that using too much fertilizers will lead to increased pollution of waterways and the air. Currently, the global average for nitrogen use efficiency is approximately 0.4, meaning 40% of the total nitrogen added to cropland goes into the harvested crop, while 60% is lost to the environment, says a study. More than half of the world's population is nourished by food grown with fertilizers containing synthetic nitrogen, which is needed to produce high crop yields. Plants take the nitrogen they need to grow, and the excess is left in the ground, water and air. This results in significant emissions of nitrous oxide, a potent greenhouse and ozone depleting gas, and other forms of nitrogen pollution, including eutrophication of lakes, rivers, and contamination of river water. An enhanced efficiency of use of nitrogen is imperative for both food production and environment. This is what author talking about. 60% is lost, goes as wastage, causing pollution. We need to reduce that. So enhanced efficiency is imperative. Production of synthetic nitrogen fertilizers cannot be stopped as it will adversely affect global food security. Passage doesn't mention this. Alternatives to crops that require excess of nitrogen should be identified and cultivated, seems like a particular solution which is not mentioned in the passage. Conventional agriculture using synthetic fertilizers should be replaced with agroforestry, agroecosystems and organic farming. No mention about these in the passage. So answer is A, most logical, rational and crucial message. Along with sustainable lifestyles, climate justice is regarded as a significant principle in environmental parlance. Both the principles have bearings on political and economic choices of the nation. So far, in our climate change summits or compacts, both the principles have eluded consensus among nations. Justice in the judicial sense is well defined. However, in the context of climate change, it has scientific as well as socio-political connotations. The crucial question in the next few years will be how resources, technologies and regulations are used to support the victims of climate change. Justice in climate is not confined to actions relating to mitigation but includes the wider notion of support for adaptation to climate change and a compensation for loss and damage. So we are talking about climate justice as a whole. What does it mean? Climate justice should be ingrained in detail in the rules of all the new climate compacts or agreements. This sounds sensible. Justice in climate change is not confined to actions relating to migration, but includes wider notion of support for adaptation to climate change and compensation for loss and damage. And from this sentence, we can say this is sensible. Environmental resources are unevenly distributed and exploited across the globe. We are talking about climate justice here, not sensible. There is an impending issue of dealing with a huge number of climate change victims or climate refugees. Climate justice we are talking about as a whole. Climate change in all its connotations is mostly due to developed countries and therefore their share of burden should be more. Nowhere it is mentioned in the passage. So answer is A. A principal P becomes Q in 1 year when compounded half yearly with R% annual rate of interest. If the same principal P becomes Q in 1 year when compounded annually with S% annual rate of interest, then which one of the following is correct? Q is equal to P into 1 plus rate of interest half yearly. Per year R%, half yearly R by 2. R by 2 into 100 for 1 year. So 2 half years. So N is 2. This is a compound interest formula. If the same principal P becomes Q in 1 year when compounded annually with S% annual rate of interest. So S by 100. Now let's equate both of these because Q is same. P into 1 plus R by 200 whole square is equal to P into 1 plus S by 100. P cancels out. 1 plus R by 200 whole square is equal to 1 plus S by 100. See, this equation is true for any value of R and S. And it looks highly difficult to deduce these relationships using these equations. Since this equation is true for any value of R, let's substitute a particular value of R and find out what is S. I want to make the thing super easy. So taking R as 200. So that 200 by 200 it cancels out. So 1 plus 1 whole square is equal to 1 plus S by 100. If at all you wanted to take S as something, take S as 300. So 1 plus 3 that is equal to this. So 4 you are having under root of 4 is 2. If you take S as 100, you would be having under root of 2. Again you are complicating the problem. I don't want to deal with under root and anything. I just took R so that I can find out S easily. So this is 4. 4 is equal to 1 plus S by 100. S by 100 is equal to 3. S is 300. So 200 is lesser than 300. R is less than S. This relation we got. Answer C. How many natural numbers are there which give a remainder of 31 when 1186 is divided by these natural numbers? Say you are dividing 1186 with a particular natural number, getting quotient Q, remainder 31. Now N into Q is 1155. If you see, this is divisible by 11. 5 plus 1, 6. 5 plus 1, 6. 6 minus 6, 0. So it is divisible by 11. 11 ones are 11. 0, 11 fives are 55. Now 105. 11 into 21 fives are. 21 is 3 into 7. So 11 into 3 into 7 into 5. Let's write like this. 3 into 5 into 7 into 11. See, to get a remainder 31, this N should be greater than 31. Kindly see this. You cannot have N as 3, 5, 7 or 11 and get the remainder 31. For 3 the remainders are 0 to 2. For 5, 0 to 4. For 7, 0 to 6. For 11, 0 to 10. So we have to combine these factors and make them greater than 31. Then yes, we will be having the remainder 31. Which all combinations of these factors give us more than 31? 3 11s are 33. 3 5s are 15 less than 31. 3 7s are 21 less than 31. 3 11s are 33. So this is greater than 31. This is one combination. 5 7s are 35. 5 11s are 55. 7 11s are 77. We combine two factors till now. Now 3 into 5 into 7. I am not going to simplify this. This is definitely greater than 31. 3 into 5 into 11. 3 into 7 into 11. 5 into 7 into 11. 4C3. 4C3 is 4C1. That is 4. So 4 such combinations. You cannot use 4C2 concept here because some are less than 31. Now all 4 factors combined, 3 into 5 into 7 into 11, that is 1155. When you divide 1186 with 1155, you will be getting remainder 31. So 4 plus 4 plus 1, 9. Answer D.